Hey everybody, I'm Paul. I'm the head of community for DoK. Thanks for joining us for the talk for our town hall. Again, apologies for the streaming issues. Um, Luckily, we host all these on YouTube, so you can watch them later. Yeah, we have a great talk with you today with George Hantzaras. Sorry if I pronounced your name incorrectly. George Hantzaras and Dan McKean from MongoDB. Before I let them take over, I'm gonna share my screen. I have some slides to share. So 1 second here. Bear with me. Okay, slideshow. So, oops. All right, cool. So yeah, thanks for joining us today. First, I just want to give a say thank you to our DoK community platinum sponsor. So EDB just joined us as a platinum sponsor. So thanks for joining us and allowing us to do these live streams and bring people on to talk to the community. I also wanted to highlight that DoK Day North America, which happened, of course, in November. All those talks are available now on YouTube. So if you scan that QR code, that will take you to that page. We have a bunch of QR codes on these slides, so keep your phones out if you want to check everything out. But there's a lot of great talks that if you weren't able to attend live, they're all available there now. So, of course, KubeCon EU is also coming up, and we do have DoK Day at KubeCon London. Schedule will be announced on January 23rd, the next week. Also, just wanted to let you know that the future of data on Kubernetes from database management to AI Foundation, which was a panel that we submitted, is now available, or sorry, has been accepted. So we'll be there doing that panel. So yeah, register. And just so you know, if you want to attend DoK Day, you do need to get the all access pass. That will give you access to all of the co-located events. So you should check that out. I wanted to highlight a project that we've been working on in the community, which is the Get Started guide. It's meant to help people who are just getting started in this area, running stateful workloads on Kubernetes, sort of a guide to get going. Of course, we're also accepting contributions, so it's on GitHub. You can submit a pull request, and if you have questions, feel free to reach out to me in the DoK SIG channel. And then I want to thank our contributors as well. So coming up next month, our town hall, we have Divine Odazi. He's a technology evangelist at Several Nines, and he's going to be doing a talk called DBA in the Age of Kubernetes. In Kubernetes operators, evolving roles, and collaboration. So check that out next month. Hopefully we'll have the live stream figured out by then. But yeah, that's what's coming up. And then, of course, if you're interested in getting involved in the community, if you scan that QR code, it'll take you to the community page. And then we're always also looking for community sponsors that just help us put on events like this and help us do DoK Day and all those fun things. So for now, I'm going to hand things over to Dan and George to get things started.
Thank you very much, Paul. Okay, I'll just share my screen and then we will jump straight in.
Oh yeah, I'll say one more thing before I mute myself. Feel free to add your questions in the chat, and then Dan and George will try to answer those questions at the end of the talk. But you can add them in the chat whenever you feel, when you can.
Yeah, absolutely. Yeah, we're happy to answer questions at the end. Cool. So yeah, today we're going to talk to you about building a global scale data platform with Kubernetes and MongoDB. Hopefully there'll be some information and learnings along the way to kind of better understand the challenges of doing. Sorry, I've been talking for about a minute and I'm been muted the whole time, I think. Cool. Hi, I'm Dan McKean, and I'm joined by George Hantzaras, who's a colleague at MongoDB. Today we're going to be talking to you about building a global scale data platform with Kubernetes and MongoDB, with hopefully some kind of general bits of information that might be useful, even if you consider a different database. But we are biased. We will be recommending MongoDB. This title is really a fancy title for us talking about how to run MongoDB across multiple Kubernetes clusters, which could be running anywhere. George.
So yeah, as Dan mentioned, we'll be focusing more on the global scale rather on the building a foundational DBaaS. We've seen a few presentations on that. So we'll start by touching upon kind of Kubernetes multi-cluster considerations, and then we'll get into the details of what we do in order to run the most performant and the most resilient MongoDB deployments. And that happens across multiple Kubernetes clusters, multiple regions, multiple clouds, and so on.
Cool. So we're going to start with a quick look at some of the complexity that needs consideration when dealing with multi-cluster workloads. It's pretty obvious now that many applications these days need resilience across different geographic locations, or the reduced latency that can be a benefit of running workloads in different places and therefore closer to users. But unfortunately, you can't just run a Kubernetes cluster across multiple regions. It requires low latency between the nodes that make up the Kubernetes cluster. These low latency requirements generally prevent the Kubernetes cluster from spanning the regions, and that in turn limits the ability to run applications in a single Kubernetes cluster and across multiple locations. However, we're going to be focusing more on the solution, which is essentially running across multiple clusters, which offers a number of benefits like improved performance, reduced latency. So by hosting services closer to end users, you can reduce latency, improve application performance, and get a better user experience. You might be able to achieve better compliance with regulations through that. Some regions can have strict data sovereignty laws that require certain data be stored in specific locations. You might also have like legislation or requirements in the business sector that you're in. And finally, and largely the biggest reason for most companies is that running across multiple locations delivers high availability, better disaster recovery, and better data redundancy.
So, however, there are a few different architectural considerations that we have to think about when designing multi-cluster deployments. So the first, the high-level one is do we want to try and make the cluster seem like one, or do we want to treat them as distinct clusters? So on the left here, we have what we call the Kubernetes-centric architecture. We call it cluster federation. Essentially, this combines clusters under a shared control plane. The goal is to enable developers and operators to treat multiple Kubernetes clusters as one. And then on the right, we have the network-centric model where clusters are distinct. You're managing them as different clusters. Admins, users are aware of the existence of different clusters. They don't experience this as one cluster, and they configure them accordingly. So for a Kubernetes operator, the Kubernetes-centric cluster will look and behave like one. But for the operator to natively support multi-cluster, it needs to deploy and manage workloads on each cluster independently, using each of the clusters API service. So while federation theory, in theory, simplifies things by allowing you to treat it as one large cluster, there's no real standard that has prevailed to how you can federate services across those clusters. And at the end of the day, it's not really a single cluster, so there's this additional complexity. On the other hand, having distinct clusters can actually offer more resiliency, as one cluster failing has no direct impact on the others, as they don't share the control plane. So we're mostly focusing on the network-centric distinct clusters model. This is kind of the approach we're going to be talking mostly today. So we already supported single Kubernetes cluster deployments using our Mongo operator. So any setup that presents as one cluster as the federation we showed in the previous slide. So we wanted to build support for multiple distinct clusters using this hub cluster pattern. So the hub cluster pattern refers to a model where you have one central Kubernetes cluster, which is the hub, managing one or more additional member clusters, which we call the spoke clusters. In this setup, something in the hub cluster, usually an operator, in our case, it is the Mongo operator, serves as both the interface and the control plane for managing the workload. So this is what the user interacts with, but also it makes sure that the right workloads are scheduled in the relevant clusters, in the member clusters. Applications can be deployed across the member clusters through the operator, taking into account factors like their workload requirements, the need for geographic proximity, like for latency or regulatory issues, optimizing the use of resources, better high availability, all of those things. But having the operator is one thing. Multi-cluster is pretty impossible without kind of the right network connectivity. So first you need networking between the Kubernetes cluster. And again, we have a few options here. So in the top left, we see the VPN option, which creates a secure tunnel between the different Kubernetes clusters. In the top right, we have VPC peering. This creates a private network connection between the two VPCs that the clusters are running in. The bottom left, we have load balancers. So we expose services in the open externally, and we connect the clusters to the public internet. And lastly, we have the service mesh in the bottom right. This is the most popular option amongst our users, and this is what we usually recommend. They can provide routing, load balancing, secure communication between the clusters, and for the services running within or external to the cluster. So we found that is rarely the case. In our case, like MongoDB is rarely the first service that someone is running that spans multiple clusters. So most users have already a service mesh installed, like Istio, Linkerd, Consul, all of those. There are also cloud provider specific, like AWS has Mesh App, or Google supports the Anthos service mesh. Then after we assure we have this connectivity across clusters, we need network in and out of those clusters, so ingress and egress traffic. There again, there are a few different options. In the top left, we see load balancers. They expose services on a public IP, and they provide both ingress and egress traffic for multi-cluster ingress. Typically, typically a global load balancer balances traffic between the clusters. On the top right, we have the service meshes, enabling inter-cluster connectivity and providing routing, load balancing, and security for external access as well. The bottom left shows network policies, so we can route traffic, we can control traffic within clusters and externally. And finally, on the bottom right, we show ingress controllers managing incoming traffic. Again, this needs something directing traffic to each cluster. We typically see load balancers used for this mostly, but ingress controllers are also a popular choice to minimize the number of external IP addresses used.
So we've kind of recapped some general multi-cluster theory and some of the challenges, and now we're going to kind of dig a little bit into MongoDB's approach to this. So extensibility, one of the key Kubernetes success elements, I would say, and operators are definitely kind of one of the great ways to extend Kubernetes, and that's what we did about 7 years ago, I think, when we started building the enterprise operator. And many of you possibly already know, but an operator is a service built to extend the default control plane of Kubernetes to support the custom logic of a specific application. In our case, we kind of think of ours as a virtual DBA, because obviously we're running databases, so it saves a lot of the work of kind of the infrastructure side of things. Our operator drastically simplifies running MongoDB in Kubernetes by automating the deployment scaling the management of MongoDB clusters within Kubernetes. It leverages existing Kubernetes clusters concepts like stateful sets and persistent volumes to ensure that the data is reliably managed in a Kubernetes native way. And our operator handles things like resizing of persistent volumes, which is through stateful sets is not something currently easily automatable through Kubernetes, but is obviously super critical for database workloads. With the operator, we provide several custom resource definitions. So new custom resource types in Kubernetes to define the configuration for things like a deployment of MongoDB or our ops manager, which is our management server. Also things like users and backup configuration and so on have their own resources. And it drastically simplifies day 2 tasks as well, like upgrades, allowing you to make minimal configuration changes and then let the operator do the heavy lifting, like rolling restarts to update different members of a deployment without taking the whole thing down at the same time. And as kind of already alluded to, it supports running MongoDB and Ops Manager in Kubernetes. Before we go a little bit deeper, I do just need to touch on some of the MongoDB concepts that we're going to kind of briefly mention as we go through. So MongoDB supports replica sets or sharded clusters, where a replica set is a number of copies of the same data. You have one primary for write operations and multiple secondaries. This offers some degree of horizontal scalability for read operations, but not write. But it does offer resilience as the same data is replicated across the members of the replica set. Sharding, however, scales both read and write operations with data divided into different shards. Each shard is effectively a replica set. And so you are adding an extra write member for each shard that you create, as well as the resilience of the read members, the secondaries. Shards are available via MongoS, which acts as a router and uses its own replica set called a config server to store metadata. So as well as scaling write capabilities, sharding allows you to distribute data across multiple geographic locations. Different shards can be set up to overlap the same regions or to reside in completely different regions, which is great for a global user base, for low latency requirements, or potentially to meet regulations. And then sharding allows you to scale out seamlessly by adding new shards and rebalancing the data, scaling performance as the application grows. So just some kind of context for what we're going to be talking about. So now moving on a little bit to how we actually run MongoDB in Kubernetes, particularly in a multi-cluster setup. The operator is installed in one of the Kubernetes clusters, and because we're following the hub pattern that George kind of talked us through earlier, we call that the central cluster. But this can also host members of any MongoDB deployments. We're using role-based access control on all the clusters to provide the access that the operator needs to each of the cluster's API servers, and then the credentials are stored in a kubeconfig secret on the same cluster as the operator, which is shown there in the middle. Creation of the RBAC and the kubeconfig can be done manually or via GitOps, but we also offer a kubectl plugin to simplify the setup in the MongoDB scenario. We've got custom resources that define the MongoDB resources, and they're applied into the same cluster as the operator. The operator reads the custom resources and deploys Kubernetes resources to the specified Kubernetes clusters. So this includes deploying things like config maps, services, and stateful sets that are all used to run MongoDB in Kubernetes. In this case, we're showing stateful sets on each of the member clusters, which are running a replica set spanning the clusters. But it could just as easily be Ops Manager, the management server I mentioned, or sharded cluster deployments. Each stateful set in each separate cluster is independent of each other, but the MongoDB application running within is configured to form the replica set. And the operator monitors the health of the deployed resources by watching events on the other clusters and periodically checking a health endpoint to check that the clusters are actually available in general. So that previous diagram showed a replica set in a very generic setup, but we're going to walk through the setup of a multi-cluster sharded deployment across 3 Kubernetes clusters that we're pretending exist. This isn't a live demo because there's lots of gaps in this, and it's good to be able to kind of talk through the theory of what we're doing and when. Excuse me. We're going to be assuming that the clusters are all set up here, and also that there's a service mesh in place to provide the inter-cluster networking that the application needs. We're also going to kind of be assuming that it's done in a way where there's no extra configuration needed to MongoDB to support it. So it's effectively transparent and allows open connectivity between the clusters that are talking to each other as if they're independent, as if they're internal to each other. So we're going to start by setting up the operator. And technically, there's these kind of 3 steps involved: creating the RBAC on each cluster, creating the kubeconfig secret where the operator is running, and then installing the operator. Although we support doing it manually and we provide all the documentation to do it through something like automation or GitOps, we also have a kubectl plugin to automate these steps. And so with one command and a few parameters, you can effectively do all of that. You can set up the RBAC, create the kubeconfig secret. And importantly, this plugin pulls the CA data and the token that we need from the service accounts created on each cluster and populates those into the kubeconfig secret, which is a slightly fiddly step if you're doing it through GitOps, where you have to create the service accounts and then pull that data out to populate it into a kubeconfig secret. So if you can use the kube control plugin, we highly recommend it. Installation of the operator is almost as simple as running that command. We've got a Helm script, so yeah, the Helm repo that we maintain, a Helm chart, sorry, and then run Helm upgrade to install the operator. I'm not going to break this down line by line. It's pretty standard kind of Helm and a few parameters, but we do have more guidance in the docs materials that we'll be linking to from the end if you're interested in trying this out. One of the main things to note is setting the fully qualified domain names for each cluster down here on line 11. That's a pretty critical step. Sorry, it's George's turn.
Yeah, so yeah, when the operator is now installed, deploying a sharded MongoDB cluster across multiple Kubernetes clusters is done with a single CRD. We have a single custom resource that's applied into the hub cluster. So we're going to look at the configuration for multi-cluster sharded deployment in three chunks. The first part of the custom resource is kind of a lot of the basics. So in line 2, we have the MongoDB resource. That's the resource that we define for all of our deployments. On line 8, we define the type of the deployment, and here we say that it's going to be a sharded cluster, which on line 6 we can see it's going to have 3 shards, and on line 7, that's the important part here, we see that the topology is going to be multi-cluster. And then it's really from line 15 that we start to see the sharding configuration. In the cluster spec list, we're setting the defaults for all shards. So each shard is going to have to be 3 members, 1 per cluster. And then for each, shard, the member in, so for each shard, the member in Kubernetes member cluster 0 is going to have election priority 20. We see that in line 21. Yes, exactly there. So this is going to make the member, this member, the primary within the shard. So we've set up the different shards, but it's also possible to customize them individually using shard overrides. So let's say you want shard 0 to have greater resilience or read performance. So you can set that cluster to have 2 members in cluster 0, 2 members in cluster 1, and 1 member in cluster 2. If shard 0 also holds data for users that live in the same region as member cluster 1, you might also want the primary member of the shard to be there by default to minimize latency. To do that, you can set the priority higher than other members. This per shard customization is new in our operator, but it's now supported for sharded deployments regardless of whether they're on a single MongoDB cluster or spanning many. Now, looking further down into our YAML file, we can also see the configuration for the config server and the MongoOS. On the diagram, these are on the far right. So clients connect to the shards via the MongoOS, which depends on the config server for the metadata about which data is in which shard. So we've got a config server and a MongoOS in each of the Kubernetes clusters to provide resilience in case we lose one cluster or one region. Believe it or not, that's kind of it. You apply this custom resource into a central Kubernetes cluster alongside the operator. For testing, that might be done by kubectl, but then for production purposes, you might go and build a DBaaS using a GitOps workflow, a GitOps interface in your platform to expose this to end users, allowing them to manage resources in a central Git repository. Once we apply this CRD, the operator automates all of the heavy lifting, deploys all of the stateful sets, storage to run all of the different components. And it also simplifies future changes like upgrades, MongoDB version upgrades. Those are going to be done on a rolling fashion managed by the operator to avoid downtime. Deployment can take 10 to 15 minutes, depending on the size and the scale of the deployment. Back to Dan.
So yeah, we're really excited to be showing this work. It's the support of multi-cluster sharding is the culmination of kind of 3 years worth of work to first support replica sets, then Ops Manager, and now sharded clusters. And we're really excited at the reception it's getting amongst customers. The high level of resilience of MongoDB combined with Kubernetes plays together really nicely. So it brings MongoDB's native capabilities to meet the highest scalability and resilience requirements. And it's also a really interesting thing to work on kind of multi-cluster support in this space. So and that's it for the kind of talking portion. But we are very happy to take questions. You can use this link or this QR code to access some materials that we've provided about how this all works. And yeah, we're happy to take some questions now if folks have them. I've seen some popping up in the chat in the meantime.
Yeah, thanks for the chat. For that talk. And there's one question from Shiva. It says, "Is there open source version of the operator to try out? And then also, did you try this in AKS Azure?"
An open source version of the operator. We do have a community operator, and that is open source. This one that we're kind of showing, or we've shown right now, is not currently open source. But we are actually in the process of merging the two operators to create one new open source operator. It won't immediately enable multi-cluster with MongoDB community, which is the free version. But that's something we are considering adding, but the operator itself will be open source. So yes, possibly, but at the very least, within a few months, there'll be kind of one open source operator where this is all supported, and you can potentially have a poke around at how we've done it. And the second part, I don't think we've specifically tried it in AKS, but everything we do, we base on base Kubernetes. and ensure we don't leverage any kind of special functionality that's not available there. So we do know that the operator will run in AKS and almost all CNCF certified flavors of Kubernetes. So I'd bet my car on the fact that it would work. I shouldn't say that because there's always something that's wrong, but you know what I mean. We're very confident.
Sure. So, well, and if anybody else has questions, feel free to add them. But I'd say, so like, what are some of the main technical challenges you encountered when implementing cross-cloud data replication?
So we haven't gone into massive depth in this presentation about that. But if you give me a second, a couple of our engineers did recently do a more kind of how we produce the operator kind of talk.
Sure.
I'll see if I can find that quickly. George, I don't know if you have the link and you could talk through some of that stuff.
Let me see.
And by the way, no worries if it's too hard to pull that up right now. I mean, feel free to, you can even add it into Slack later, if you want to.
Give me 2 seconds.
Sure.
Okay. Yeah, I can talk about some of the challenges. So working around the federation and kind of looking for standards in kind of trying to centrally manage multiple clusters was kind of one area of challenge that the kind of the engineering team faced. Considering how to do multi-cluster services, how to kind of set up the services across multiple clusters, not necessarily to work in a way that was aware of each other, but in a way that kind of was consistent across different clusters. I know that one of the challenges we faced was around kind of cluster inventory. Trying to allow customers to define which different clusters they wanted to manage, and also to provide a nice standardized way or as standardized as possible way to have this operator in one cluster effectively manage multiple clusters. That was a significant challenge. I couldn't necessarily personally speak to a lot of these in massive depth. George, have you got thoughts to
Yeah,
add?
just on the data layer, specifically on the cross-cluster replication of data, I would say over the years we've had a few crazy ideas, kind of creating a multi-cluster primitives, like creating a multi-cluster stateful set or anything like that. We have been lucky because of kind of the design of MongoDB, and essentially all of the replication and all of the data management is handled by the core server, and then we kind of have to manage the service and just provide the right volumes and kind of that thing. So yeah, for us, it's been a lucky journey in that sense that we haven't dug into it. Yeah, some crazy idea, like the craziest idea we've had was this, I think the multi-cluster stateful set spanning multiple clusters with PVCs in each cluster, which we ended up not having to go down that path. But yeah, I think that's something that the community has discussed here and there.
Okay, great, cool. Well, I think we don't see any other questions coming in, but yeah, I want to first say thank you to Dan and George, also to everybody else for bearing with us with our streaming issues. I'm glad you made it. Of course, I'm gonna put this on YouTube, where it'll be available in perpetuity. So yeah, if there's no more questions, I guess that's it for us for today. So yeah, come check us out next month on February 20th. I'll do my best to have all these streaming challenges worked out. But yeah, thanks again, and we'll see you at the next one. All right,
Thank
Thank
you.
you.
all right, bye-bye.
Bye.